In order to be successful at finding the probability of two independent events as we're doing today, we need to brush up a little on our fractions. So let's take a look at some candy bars here. So I have 1/4 of a candy bar. And what that means is I have a candy bar that's cut into 4 equal pieces. That's my denominator, 4. And I have one of those pieces. That's my numerator, 1. And I'm going to add some more candy bar. I want some more candy bar. So I'm going to add another 1/4 to it. So 1/4 plus 1/4. And you notice they're cut into the same sizes. This one is the same size as this one. And that's going to give me 2/4. So now I have 2 pieces. 4 pieces, 1, 2, 3, 4. I have 2 of the 4. But we say this is not in its simplest terms because I could cut this into equal pieces, a different size, and not change its value. If I cut this in half, I could say I have 2 pieces to make a whole, and I have one of those pieces. Now, the algorithm for doing this is to take 2/4 and ask, what's the greatest common divisor between 4 and 2? Can these two numbers be divided by something, both be divided by a number evenly? And they can. They both can be divided by 2. 4 divided by 2 is 2, and 2 divided by 2 is 1. And if I multiply a number, and 2 over 2, or 2 out of 2, is the same as 1 whole. As we remember, if I divide a number by 1, I don't change its value. And notice I didn't change its value. I have the same amount of chocolate. Either 2/4 is the same as 1/2. So my answer is, in its simplest terms, 1/2. 1/4, 1/4, 2/4, and that's equivalent to 1/2. Because these are both divisible by 2. 1/2. Same size, didn't change the size. Let's look at another one. So let's say now I have 1/4 plus 1/2. And then this is how much I have. Now, in order to put pieces together, I can't compare this one, to this one. Why can't I compare this one to this one? Is it fair to say that this is one piece and this is one piece? Absolutely not. Why not? This one is larger, represents a greater portion than this one. So let me break it down. I'm going to have to cut these into more pieces. The 2 pieces need to be cut into the same amount of pieces. This is cut into 2 pieces. This one's cut into 4 pieces. See the 4 here? It's cut into 4 pieces. This is cut into 2 pieces. And I have to ask myself, is there a way to cut them into the same amount, the same number of pieces? Well, yeah, that would be called my greatest common denominator. And that's looking at multiples. I ask myself, let's see, 4, 8, and is there a number that I list out the multiples of 4, and I ask myself, is there a number that this can be divided? Can this number be divided by 2 evenly? And with my first one, 4, I find it sure can. So my common denominator is going to be 4. And yes, I can cut this into 4 equal pieces and still not change this shape. So this becomes 2/4. So 1/4 plus 2/4 equals 3/4 right here. So that's kind of how I work it out. Find the common denominator. Here's a visual representation of that. Let's go on. And let's say I have 1/3 plus 1/4. So it would mean I have, picture the candy bars. I have a candy bar cut into 3 pieces, and I have one of the pieces. Here's a candy bar that's cut into 4 pieces, and there's one of the pieces. They're not the same size because this candy bar has been cut into 4 pieces. This has been cut into 3, and the one doesn't add up. So I need to find a common denominator. I start with a larger number and write the multiples of that number. 4, 8, 12. And as soon as I get to a number that can be divided by 3 evenly, that's my common denominator. It looks like I came up with 12. So 1/3 is going to be equal something over 12. And 1/4 is going to be equal to something over 12. And because 12 can be divided by 3 and 4 evenly, I can cut these into 12 pieces and not change its value. So how many more cuts do I have to make? What times 3 is 12? Well, 4 times 3 is 12. So I multiply the denominator by 4. I also multiply the numerator by 4. So it's 4 12s. 1/3 is 4 12s. What did I multiply the 4 by? Well, 3 to get 12. Then I also multiply the numerator by 3. 1 times 3 is 3. I have 3 12s. And now I can put the pieces together. 4 plus 3 is 7, and I have 7 12ths of the candy bar right here. So it's a little review on the addition of fractions, which we'll be using when we determine the probability of two independent events.